At Merck's, I've been using EMF a lot the last 2 years to implement the oomph technology. So EMF in general is very good for sort of rapid prototyping. Ica is another sort of modeling junkie, so when we build something new, we want something working immediately, so we model it and a lot of things just work out of the box. But we wanted to make a lot of the UI a little sexier and make things a little user-friendly, so I'll show you some of the cool things that we have in oomph that are really quite generic features that I hope to factor back into the EMF framework, time permitting at some point. And so one of the things that oomph allows you to do is to open all of the setup models. And the setup models are linked, so everything is reachable from sort of a root index file. And we have this navigator for opening that index file. You'll see when I open it, it's basically opened instantly. If I actually had an internet connection, it might take 2 or 3 seconds where a little progress dialog comes up. So you think, well, that's a small model. Of course it loaded quickly. But in fact, there's an entire resource set full of setup resources that have been loaded here at this point. So if I select them all, you see there's 57 resources got loaded when I opened that editor. So in order to be able to do something like that efficiently, and in fact you'll see a lot of these URIs are HTTP, HTTPS URIs. So we really do generally load these things from the internet the way you would expect from seeing these URIs. So we have this concept of a resource mirror, and it starts out with a resource set and it loads the initial resource, and in a thread-safe way it creates that resource and loads it on its own thread, and after loading it, it visits the entire contents, all of the cross-references, and it queues up jobs in the pool to load the additional resources. So there's a pool of 10 threads, all of them loading resources and crawling them in parallel and queuing up the next set of jobs to load those things. So and one of the reasons why we did this is we do a lot of background processing, and proxy resolves on multiple threads are really not thread safe. So this sort of eager crawling and proxy resolution gives us a model that's completely thread safe to use across multiple threads because all proxies have been sort of instantly resolved. So we added some enhancements as well to the properties view. You'll notice there's no scroll bar, and as I go to the different types of objects, the columns are always resized so that that first column is as small as possible, and the remaining column, there might be a scroll bar depending on there being a lot of contents, but some basic automatic resizing, which is always kind of a PETA with a properties view. It never seems to adapt to the data that you want to show. We've also added some really cool, so I think one of the coolest features, and is completely generic, it's support for find. So this is the identical find dialog that you get when you do find in a text view. We have injected one additional setting in it. So when you do this, the find in this tree view, you can search just the labels in the tree itself, but you can also search the values of attributes in the properties view. So for example here, I might tell it to search for Maven. And now it's not working. Let me try again. I think part of the problem is I don't know we'll even see the contrast on the... here we go. So you see, it was selecting the properties, but here you see it's selected the text in the actual view. And if I hit next, you see it searched the properties and selected the matching text in that properties view. So it really is like the sort of find that you expect in a text editor, that it searches through everything, and if it's a regular expression, you see exactly which part of the view matched. So that's especially important in views like this one, where the resource set is gigantic and you want to find some individual piece. You usually have some sense of what to look for to find it quickly in that tree. In terms of all this sort of offline and caching support, I can show you quickly where you can find some of these classes, if I can find my IDEs. So I've highlighted here some of the key classes that you could have a look at in oomph. There's this class called Resource Mirror that does all this parallel loading. And there's a class called the ECF URI handler. And it's really a generalization of EMF's basic URI handler. It uses ECF, so it properly sets up network proxies. So if you're behind a corporate firewall, it deals with that issue. It also deals with authentication. So a lot of times I work for some companies where I need setups for setting up the development environment for that company, and those are password protected, so I can have setup files that require authentication in order to be able to load them, and this ECF URI handler handles that automatically. A prompt will come up and you can enter a password and get secure access to those things. And we've also made things quite dynamically extensible. So if we go in this IDE here and open the catalog and look for the Maven import task, you can see here it's highlighted with a nice icon, but in fact this is a dynamic model. We publish our eCore models to a website, and those dynamic models are available to read the dynamic instances, and we have them decorated with information that we can show the same icons as when that installation is actually there. So we've made heavy use of dynamic EMF so that we can read setup models even when the implementations of those models aren't installed in the IDE that you're working on. And have nice extensibility features that way as well, so you're all familiar with this sort of new child creation, that I can create a new child. And we have this additional tasks, and those are tasks that the implementations are not installed in this IDE, but we know these tasks exist, and if you pick that, it will install them into this IDE, and of course Eclipse needs to restart, and then you can actually use these tasks and run them. I think we're running quickly, 3 more minutes. So one of the things I want to show you as well is kind of this cool, if I can find the right IDE. So we have a cool wrapper model. So we have something called the all preferences preference, and it shows you the entire preference tree in Eclipse. So if you're familiar with Eclipse preferences, they have this concept of nodes that are recursive, and at the sort of leaves they have properties. So I can view that in here, but I can also open that up in this properties editor, and I can inspect all of the preferences that are available in this tree. So what are all the defaults that are being set, and the bundle defaults, and in fact we've even hooked in the secure storage, and in fact with a couple of tricks I can go and see what passwords I have cached in my secure storage. And this editor actually does save, and when it saves, it pushes the information in the wrapper out to the actual underlying preference store, so you can go crazy here and edit your preferences and look up your remembered passwords and things like that, and change them and save them back. So that's just some of the cool things. Actually, the last one I really should show, the drag and drop, is really cool. So I can take any task in EMF in the setup editor, and I can go to text editor, and I can drop that piece of text. And if I have that piece of text, so I just copied it to my clipboard. I have to find somewhere editable in here. I think that will be editable. Good point. Open my user, and I can paste that task into my user. So we have proper system clipboard support. We support a whole bunch of transfer types, so you can drag a URL from a browser, and in Skype you can drag your task to Skype, and the other guy copies it and drops it into their editor. So most of this is completely generic that I would like to refactor into EMF, but it's not been done at this point. So So I think I have reached my time limit, so I have time for a question or two, and then the next person can come and set up already. Yes.
Seems like you've done all of it.
Okay, so my name is Udo Hafermann. I work for Software AG, a worldwide company based in Darmstadt. Our products and also services help other big companies digitize their business. I want to talk about an approach for modeling things for the Internet of Things. So the good thing about this brief format is that I'm not going to talk about what the Internet of Things is, but the motivation of behind this project is how heterogeneous and how distributed this world is. So we have these things or components that are of very different kinds, and they are distributed across very different kinds of nodes. So you have capabilities, I don't know, tiny devices with, say, less than 64K code and little memory, and you have regular devices which can execute Java and so on. And we want to avoid specifically coding our logic for each of these different kinds of things. We want to use modeling. And that's behind this project called HEADS, Heterogeneous and Distributed Services. It's a project funded partly by the European Commission, started late in 2013 and more or less in the middle now. As usual for these kind of projects, there is a mix of industrial and research partners. We are one of the industry partners. And you can find out more details if you visit our project website, headsproject.eu. Also on GitHub you'll find lots of information and code and examples and tutorials to download. So in a nutshell, we want to specify the behavior of the things through the HEADS modeling language, and also we want to specify the configuration and the deployment through modeling, and also there is a transformation framework for transforming that into executable code, and also extensible in the sense that you can add new kinds of devices and even platforms by using the framework without having to change the original modeling language. There is Eclipse IDE support. You can either download the HEADS IDE from the project website, or you can install the plugins into your Eclipse. So there is a language, modeling language for specifying the behavior. The syntax looks quite readable, I think. To define a thing, you define its properties, you define some logic, you define ports and the kinds of messages that you can send and receive. For the logic, one very useful paradigm are state machines. In the modeling language directly you have roughly what you get in UML2 for state machines. Also there is, we're working on the capability of adding complex event processing to the setup. That's a longer story. Event processing is very useful because when you're working in this environment with lots of traffic, well, a state machine can become clumsy. Any kind of logic can become clumsy if the patterns become complex. So this approach is very useful in the IoT. Yesterday there was a talk about using neural networks on such devices. That would also be an approach, but we haven't considered that one. But that's event processing is a longer story, so I'm not going to touch that. And if you need to, you can also include native libraries native to the devices you're addressing, and include native code in your definitions. But that hopefully will not be necessary, or only when you're bringing in a new kind of thing as a provider of new platforms. So when you are defining a thing, you also define the configurations consisting of instances and their connectors. So you connect up the ports, the matching ones, they have the message types have to match. And then you can generate code for already a wide array of targets, languages, and also the platform itself. And if you want, you're already finished because the code will already be executable. So if you're generating Java code or JavaScript code, you can already run that on a Node.js or whatever you have. But usually you want to deploy it on a distributed system, so you'll use the deployment modeling language to define your deployment scenario. And there you will be talking about nodes and channels and groups of nodes. And again, code will be generated. Partly this will be interpreted to bring the runtimes to the appropriate devices. Partly there will be even a piece of runtime deployed with the code, because the intent is to have a live model at runtime that you can manipulate. So there is a model editor, a web UI, where you can inspect your system and even make live changes by changing the model, and these relevant parts will be redeployed. Okay, so that's more or less the story. So the intent is that you, as the service developer, are mainly concerned with your reasonably abstract model, and you have the experts take care of extending the framework in a way that you can transform that model into something that will run on the specific platform, so that you don't have to know how to code C even to be able to deploy a thing, define the behavior for a C-based device. And then the generated code will be deployed and brought onto the devices. Okay, I think I've been very quick. So there's much more to tell and to read up on, so please visit our website, hetzproject.eu, and also the GitHub site, which you'll also find reference from there. And there are two sites where you can find more details on the modeling language itself, called ThingML, and the deployment and the model at runtime system, originally called Kevery, and now both brought together under the Hetz project. Okay, I'm done. Any questions? Okay, so thank you.
Right, I'm Blink. I'm afraid I have a disgusting number of jobs. If I keep that separate, it may not bang. Right, I have a dreadful number of jobs in OCL and QVT at Eclipse and OMG, because unfortunately everyone else has run away and left me holding the baby. So if you want to come and help, please do. But basically, this talk is about getting the OCL debugger working, and so I'll give you a quick context of what OCL is if you're not familiar with it, why a debugger is hard, and probably of most interest to you is perhaps the EMF and Eclipse techniques that we actually use to make it work. So the general context for OCL is we're keen on the specification world as opposed to the implementation world, and obviously we all like models, and ECore is a fairly good specification stroke implementation language. UML's more specification. Hextext is actually a specification. But better than models are rich models. And so in the implementation world, you've got XBase and ECore plus Java and such like, making things better. But really, we're interested in applications and programs so that we can actually achieve something. And where OCL fits in is OCL is an executable specification language, so that enables us to get rich models and behavior, and OCL in ECore gives you a binding so that you can use both together, and they basically lead on to imperative and declarative transformation languages so that we can do things with a vengeance with models. I'm sure all of you are familiar with launching a Java debugger. Basically, with the aid of a command line or a launcher, you tell the Java debugger to load your program, which then loads your data, and you're up and running, and it all works beautifully, pretty much with a single mouse selection, because the context flows through. OCL, unfortunately, is different, because OCL is useless by itself. It has to work with something else to provide it with models. So to make an OCL debugger work, we need to provide a constraint. That's the program we're going to execute. We need some data to execute over it, and we need a command line. So kind of we need to make multiple mouse selections to give the debugger something to work with, and that's a bit troublesome. And so explaining that is what I'll be moving on to. So I'm sure you're hopefully all well familiar with the architecture of an EMF application. It's got a resource set with some resources and some E-objects, and that's wonderful and useful. When you put that on Eclipse with a UI, you can select an E-object using some suitable editor that then can be published via the iSelection so that potentially an OCL application or something else can get hold of the selection and so improve your application. And I will show you that as a quick demo in a couple of slides. A second technique that EMF provides is that we have this basic chain of modeling application at the bottom. If we want to validate a model, then we tell a diagnostician to have a look at the resource set and make use of its validation registry and its validators and constraints to tell us how good or otherwise our model may be. And what we can do to this is, with the aid of a menu action, we can install extra things into the validation registry that will have OCL facilities, so that now when you validate, you will get some OCL validation in addition to the traditional EMF validation. So if I take a shot at my first mini demo, I have my favorite victim here, which is the Xtext arithmetics example. So it's an Xtext grammar. That is an EMF model, albeit disguised behind a concrete syntax. And so I can select something in there. I'm not looking at what I'm reading. I've got the wrong file open. Come back. That is the Xtext grammar. Which is what I thought I was showing you. I was showing you the added value OCL. So if I select something there, then that is published throughout Eclipse via an iSelection. And if I open the OCL Xtext console, then we see here at its top that it tells me what the selection is. So if I change the selection, it changes. And I can practice doing OCL things by typing an OCL expression at the bottom, and it tells me that that's actually an assignment, and I can do a bit of reflection. Oh, I'm not selecting what I practiced. Oh, no. Right, well, I've got to keep moving. That should tell me what's happening, just as it would have on my slide. So it should have told me that we'd actually got that feature in the property. But there isn't time to debug that online. So if it hasn't all gone hopelessly wrong, what I can now do is some OCL injection. So in the OCL, I can load a document, at which point the dialog pops up, and I can drag and drop that. Maybe Ed's drag and drop will allow me to bypass a dialog for this. But this should have now loaded some extra stuff into the Xtext editor, so that I've got some warnings down there because of my extra constraints. If I type in an extra bit of code, that will prove to be something that makes it unhappy. I've got an extra import, and I have a warning on that, and that tells me that the extra constraint, no anonymous imports, has been violated, because I have decided that I will have a style rule that all imports must have an as something. And so if we go to the extra OCL, that's caused by this bit that says, in the context of a reference model, the no anonymous inputs requires that the alias is not null. And so that is now reflected in the Xtext editor. So if I carry on with the slides. This is the basic validation I've shown you. We can expand on this by having another application that makes use of the Xtext selection to give us a different validation algorithm so that you can find out what we're doing, go at the resource set, go over the resource set, and look at the validation in a different way. And consequently, because we have a different application, we can now attach an OCL debugger to it. And so we can make use of this to actually finally get the OCL debugger started up in a way that hopefully is friendly and helpful to the users. So continuing with the demo, I can now select the OCL validity view. That is worrying. But fortunately it's recovered. On the view basically has a left-hand column where it shows all the objects. It's a tree which I could open. On the right-hand side it shows all the constraints. So here we have all the EMF constraints, so that for an E attribute there is a consistent transient that has been applied to these 4 objects. But EMF constraints are mostly not very interesting because there's lots of them and they nearly always work. What is more interesting are the extra OCL constraints that I've double-clicked to hide. Jittery fingers are not good during a demo. Right. If I expand here, I can see the extra constraints and the reference meta model. We can see we had 1 warning, and in fact it was being applied to 3 imports, 2 here in the Xtext and 1 actually in the terminals that was included. So one of these has gone wrong, and here, if I select that, I can now use the menu action debug single enabled selection. And so because I have a single selection in the validity view, I now have a selected constraint and a selected model element, which is the information I need to get OCL working. So now when I click that, I don't need to save the editor. I can now have the OCL debugger starts, and it's a debugger. I'm sure you're fairly familiar with the debugger framework. There is one thing that is notably different about it, is this is an expression debugger. So you can see that this initial highlight is actually on an A, which is a rather odd highlight. Many of you may not be aware that the debugger framework actually supports line debugging and character range debugging. And so here we have switched using the Eclipse debugger framework in the character range mode. And here, if we browse, here we can look at self, which is the reference meta model. Its alias is null. And we have pseudo properties, so we know see its container is an Xtext grammar. Basically, we can look at the name. That's the arithmetics grammar. So we have a browser through the model, and we have another pseudo the program counter, which is actually a variable expression for self. And if we look at its container, we see it's actually self.alias. So this is the same as Java. It's this in Java, it's self in OCL. So actually, we're trying to show self.alias, but self isn't there in the source text. So where it isn't there in the source text, we do the next best we can of just show that single character. So now, if I single step, it now moves on to the property call, and it now highlights alias correctly. If I step another, now it goes to the null, now it goes to the operation call, and we have these pseudo arguments, so I see that the source is null, the arguments is null, and so I can now understand why this constraint indeed failed, because the alias is null. So I'm actually able to step through the OCL constraint in the context of the user's models. I have not required the user to create a new artificial test harness in which they have copied the program in, they have recreated the user models, and of course totally lost the original problem. This is working back in the user's original domain, and so consequently it might actually work. And if I step one stage further, finally we have the expression in OCL with its owned body that's false of the constraint. That's gone. So that is basically a debugger just the way you might have expected it, but now working on OCL in the context of the Xtext editor and this has used not a single byte of change to anything in the distributed XCX code. So it's demonstrating that OCL is able to exploit Eclipse mechanisms to latch on to other applications and add value. So this debugger was basically driven by the fact that my rival Dresden OCL produced a student quality debugger in 2013. And so I looked around and we have an Excelio debugger or an Eclipse QVTO debugger. I decided to borrow the QVTO one and move it to the new Eclipse framework that is extensible for QVT, and so this was available in Luna and is obviously available in Mars as well. So in summary, we have the problem that OCL is useless by itself. It has to complement something else, and that makes it a bit hard to get the debugger working. And so by using some nice capabilities of Eclipse and EMF, we're able to latch on via the selection to get at the resource set and basically add value so that OCL is able to work with pretty much arbitrary modeling tools. Thank you. Any questions? Yep. Certainly the OCL debugger as it exists today is not perfect. There are plenty of opportunities for doing more, but something is vastly better, more than something else. If your source comes from complete OCL, then if you give the debugger a little bit of help by putting in new lines, then you can do line stepping rather than term stepping, which is more satisfactory. And when you do actually step return, it steps to the end of an iteration. But there is plenty of opportunity for improved ergonomics. But compared to the previous nothing, it's a huge improvement. Any other questions? Back to Jonas then, probably.